Okay, let's take a look at U11C&D, check your understanding. So it tells us to use Desmos to create a graph of f of x equals 2500 times 1.07. So I can't figure out how to do this on my computer. While we're doing that, I've got to do it this way. That'll slow me down a little bit. F of x equals 2500, parentheses, more parentheses than I needed, 1.087, 1.087, close the parentheses, raised to the x power. All right, so I see that. Knowing what I know about y equals a times b to the x, why can't I see the graph? Well, it looks like I actually can see the graph. Did I put it in correctly? Did I get a decimal point in there? It kind of looks like maybe I didn't get the decimal point in there. Okay, so 2500 times 1.087 to the x, I cannot see the graph on there. What I know about this is the 1.087 tells me this is growth because that's bigger than 1. But more importantly for seeing this, the 2500 is the y-intercept, and my graph only goes up to 5, 6, 7, 8 or so. So I'm going to pop in here the y-intercept is 2500, but my window only goes up to about 9. Okay, so we'll go in, we will grab the wrench here and make just a couple of changes. The negative 10 to 10, I probably am actually okay with those numbers, but I want to see up here on my biggest y value, I've got to get up to at least 2500. I'm going to put 2600 on there, and I can now see the graph in the background there and get to where I'll squeeze and manipulate here until it feels like I'm seeing the parts of the graph that are important to see. And then I'll hit the wrench again, and that happened to be from about, looks like, negative 26 to about 23, and on the y's from negative 745 to about 5,755. So yours certainly doesn't need to be exactly that. It's just something that enables you to see what's going on so that then you would be able to move around and try different things. All right, function to table with technology. Use calculator and the exponential function g of x. So I'm going to turn off f of x here and come back in. I don't know if I'm going to need that again, but I'm going to put in g of x equals 15.4 times 0.9574, missed the 5, 9574, close that parentheses, raise it to the x power. Okay. In order to complete that table, now that I've defined what g of x is, I want to know what g of these different things are. So I'm just going to ask it to tell me what is g of negative 3. And it says that is a 17.55 approximately. Below, I'm going to keep a couple of decimal points, seem to make sense on this. I don't know if rounding to 18 makes sense. Maybe it does. I guess this was 1 decimal point, so maybe 17.6 makes the most sense. And then it wants to know what is it when the x is 2. So I'm just going to delete that negative 3 out of there and ask it, what about if it's 2? That gives me a 14.1. What if it is 3.4. I'm going to type in a 3.4, and it says that's about 13.3. Delete that and put in a 10. That says 9.96, which is to 1 decimal point 10.0. Okay, when I see that, I know you can't really see with the glare on there what I'm getting, but down here it says 9.964487. Okay. Two more. It wants to know what is it when it's 50. At 50, I get about a 1.7. And at 100, put that in, and I get a 0.2. Okay, so there's using the technology to help me change to fill in a table for a particular function. Okay. Let's see, we'll turn that one off. The table below represents exponential data. Find the initial value and the common ratio, or the growth factor, and use them to write the equation. Okay, so we could do this in a couple of different ways. The way that we would have done it before is we'd take these and I'd do 128 divided by 160. I can do that on this as well. 128 divided by 160 is 0.8. So it says I'm multiplying by 0.8 every time. So if I divide by 0.8 a couple of times, I think the enter will jump me to my next line. 160 divided by 0.8 gives me a 200. That would be with the 1. And if I then divide that, that looks weird. Okay, I'm going to enter it. I wonder what happens if I divide by, I wonder if I can access that other one. Doesn't look like it. So 200 divided by 0.8 gives me a 250. So my 0, my initial value, the A, is going to be 250. The B is 0.8. So my equation is y equals 250 times 0.8 to the x power. Okay. Now, this says there's also a special way to get Desmos to find this for you. Pause the video for a second. All right, let's see. I'm going to come back in on my calculator. I'm going to delete some of those calculations that were in there. It says there's a special way to get Desmos to find this for you that is good for this, but not for a test. Okay, so let's try this out. We're going to click on the plus sign. That's right here. We click on the plus sign and select the table option. And so it throws this extra thing on there. Don't change the titles on the table, but enter the data from the table into the Desmos table. Okay, so I add a 2, and let's see where enter takes me down. So 2, 3, 4, 5, 6. 2, 3, 4, 5, and 6. And then these numbers are 160, 128, 102.4, 81.92, and 65.536. Okay, so enter the data on the next line. So the next empty line down here, I'm going to get rid of these other ones so that it matches what I'm saying here. So on the next line, type this: y, the number 1, the tilde symbol. So in here, I got to try to find my tilde. There's my tilde. Okay, so again, the y1, the tilde that it shows on here, I want an A, times, so I'll have to come back into this one, a times b, go back and grab a b, and raise it to the x1 power, x1, like that, and suddenly, so if you didn't notice before, if I turn this off, there were some points that showed up in here. These are the points that I plotted from the table. Remember, the table was green, so we've got those points in there, and if we turn this back on, it creates this line that goes through those, and it says right down here, I don't know if you can see it or not, okay, probably not so much, A is 250 and B is 0.8. When I put it in this y equals a times b to the x form, it's exactly the equation that I came up with from before. So the technology can help with that. Okay, so that's the standard C problems. Let's take a look at standard D. Using a function and a calculator to find the values of the function. Okay, so this just, on this next one, says find h of 360 when h is 12,000 times 1.009 to the x. So if we define our h of x, and we say that's equal to 12000 times, in parentheses, 1.0, I missed that point, 0.009, close the parentheses, raised to the t power, x power, doesn't really matter. Matters that I use an x there if I use an x there. Okay, so I don't know if we can see that in there. And then on my next line, I just have to say, well, tell me what h of 360 is. So I'll go back and grab my h and say, what do I get when I put a 360 in there? And the answer down here is a 301996. Okay, 301,996. My next one then, I'm going to define the function r. So r, I used to know my keyboard, of x, or r of t. It wants me to use a t. I'll go ahead and use a t. R of t is equal to 3.208 parentheses 2/9, 2 divided by 9. Desmos makes that a nice fraction for me. Get out of that and raise that to the t power. Okay, and then it wants to know what is r of negative 5/3. So I will go to r and ask it to put in a negative 5 divided by 3. And it says it is about 39.35. I guess 3 decimal places there. I'll do 3 decimal places here. 348. Okay, so just defining the function, putting them in. I really could have just typed in 3.208 times 2/9 and raised it to the negative 5/3 power as well. Okay, so now I think we're putting Desmos away for a little bit. Okay. Use the table on the right. So this is a different representation. This was equations using the calculator to calculate values. Here's a table for the function f. Y values have been rounded to the nearest hundredth. It wants to know what is f of 5. So these are the f values. These are the input values. This is asking me when I input a 5, what do I get as an output? And that shows me on the table 263.63. This one says, okay, since 4 is between 3 and 5, okay, so 4 would live in here somewhere, between the 3 and 5 as an input, then the output, the f of 4, must be between these two numbers, The small end of it, 263.63, and 311.48. So whatever f of 4 is, it must be between those two numbers. If the output, if f of x is 472.59, so the f of x, 472.59 is right there, then the x that it must be referring to is the -2. That's paired with it. An input of -2 gives me an output of 472.59, and that's what this is asking. What do you put into this to get a 472.59 out? All right, if the output is 145, 145 would fall somewhere between these two. It's between 135 and 147. So if the output's 145, the input must be between 12 and 13 based on what I can see in that table. Okay? So that's how I can approximate some things using a table of values. Hard to get exact in there, but I can see things fairly easy when I get the hang of how to do that. All right, and then finally, standard D at the advanced level, reading values and solutions from a graph. Use the graph at the right to answer the following questions. So when we ask a question like what is f of -3, we're asking what the output is for an input of -3. So we find -3 on the input axis. This, the horizontal, the x, is the input. This is outputs, the y values, the f of x values. So f of -3, that's this point that's marked here, and I can approximate that at about, it looks like it's bigger than 1.5, and so I call it maybe 1.6. Okay, f of 3 then means go find 3 as an input, look vertically from that. That looks pretty close to about 7.5 to me on the output. Okay. When we ask a question like for what value of x does f of x equal 3, we're asking for an input that leads to an output of 3. So my output axis of 3 here, this would be the point that is something comma 3, that's an output of 3, and it looks like about a -1/2 leads to an output of 3. So that's why that's about a -1/2. So let's go ahead and complete this table based on values from the graph. This is an input of -5. So we're talking about this point. It looks like it's a little below the 1. I'm going to call it about a 0.95 because it looks very close to that. When the input is 0, that looks like right about there. That feels to me like about a 3.4. Output of 2. Here's my output of 2. That looks like the input to get there was definitely a -2. Output of 5. Output of 5 is right here, so this point, something comma 5, is on that graph. It looks like about a 1.5. And an output of 10. 10 is up here as an output that kicks me out about here. That's a little bit past the 4. I'll call that maybe a 4.1 out there. So hopefully that makes sense, how we found those points, and that is the last Check Your Understanding of this semester.